Hello student, meet us again in the PID control class. Next step we are going to do a PID control with a real system which composed of DC motor and closed loop system. This experiment we have a station where motor attached to a linkage for checking a rotation position. We will control the position by command motor to move linkage at the desired angle. And we also have a potentiometer which gives a zero value at the end of each round. We use Nucleo board with a white junk code and board drive with an edge bridge. Here is the code which we have written in the previous class. But you can see at the decontrol, we also add the digital filter in it because the value from the difference of new error and the previous error will give a zero value sometime because the Nucleo board works very fast, which can cause the unstableness of decontrol. So the digital filter will fix this problem. Here we show us the feedback value from the sensor at the first line, and the second line will show a value of D controlled, and the third line will show a value from I control. And next is how can we upload code into the Nucleo board. The first thing is going to MATLAB window and then set directory at where we kept our work, otherwise it will not compile. And then go back to Weijang window, which is a target window. And then wait for a moment. And then click at the build model. And then it will upload code on the board. And then it will show the window below here. And then you can see it has to be all green. And if there is a mistake, it will show red on the box. And if it shows red in the box, so go and check an error on that box. Here we go. Let's do the experiment. First turn on the power supply. I forget to explain. The transfer function of this experiment is the station with H-bridge board drive. And this transfer function is controlled by Nucleo board. Okay, here we go again. When we already turn on the power supply. And next, the way we can connect host with Nucleo board, we have to click on run button and then set infinity time in the time box. You can see INF in a brief. And then we'll set our parameter here. And these values are already tuned at a stable state. And where you can see the value of P, I, and D. And then we're going to change a set point and observe on the graph and rotation of motor. Okay, let's do it. Click Run, and then you can check the box below. And here you can see the box below here. Yeah, this means it's already run. And then click at the scope. Click at the scope. Okay, you can see the graph. Yeah, the first graph shows the angle. And the second graph shows D control. And the third graph shows I control. Okay, then change the set point. And here you can see the motor, the first position is on 198 degrees, and then we're turning it down at here. See? The graph have changed. Okay, try again. And then I'm going to change the value up to 100 degrees. And then let's see. Okay, let's see. And this is 100 degrees. Let's check the graph. Okay, try again. Okay, try at 300 degrees. Let's see. See, the first graph is the response which already tuned. And you can see the smooth movement of the linkage with motor. See, it's very smooth. Okay, here I'm going to explain something. Yeah, let's talk about D and I control. You can see at the response graph, this is the graph that already tuned. And then look at the D control graph. When response rise up, you can see that D value will show a negative value because it's trying to retard the system. While I control is trying to speed up the system like P control. And because of the response graph has a some error, so the value of I control will decrease in some point of time. Then we are going to tune the system to make an oscillation and overshoot. And you can see I'm going to slide this Kp value up on this sliding gain. I'm going to slide up, and then we will see the oscillation. Yeah, let's see. See, this is what happened when I increase Kp value. I'm going to decrease Kp value. Yeah, and here Kp is at about 2.9, and then let's change the set point to see the response. Change it to 100 degrees. Okay, I will try again to make it clear. I'm go back to 300 degrees to see the overshoot. See? If Kp is accessed, the overshoot and oscillation will occur. Let's take a look some more to see the oscillation and overshoot. Yeah, you can see here is oscillation.
Eh?
Okay, this is already done for now. If you have any question, you can ask me online application or on Facebook.